Unmanned aerial vehicles have been a part of the warfare mainstream all around the world for decades now. Be it in combat or surveillance roles, even some of the more poorly developed military forces are using them, while the more developed ones are now testing out entire aircraft carriers devoted just to this single piece of war technology. The thing is, even though drones are a nightmare turned reality, drone carriers are still in the experimental phase. Like teenagers, none of them really know who they are, what their exact purpose is, and what the future holds. One thing we do know about drone carriers, however, is that their numbers are rising and that they're on the verge of revolutionizing naval warfare forever. Drone carriers already exist, kinda. Launching drone carriers off a carrier deck is not a revolutionary idea by any means. In July 2013, an X-47B unmanned combat air system developed by Northrop Grumman successfully landed on the USS George H.W. Bush during trials, thus completing the first ever fully autonomous carrier landing in history. The VBAT, developed by Shield AI, was created specifically to complete unmanned cargo deliveries at sea, and it has already taken off and landed on carriers hundreds of times by now, with the United States also developing a one-way attack drone called Lucas, designed to take off from ships. All of these drones use traditional aircraft carriers, or in Lucas's case, a littoral combat ship as a launching pad, but these vessels were only used during testing phases and in specific cases when the launch of onboard drones wasn't weighing the ship down. As some countries are now fully committed to the development of a drone-heavy combat doctrine, which would involve drone-dedicated carriers, it's become apparent that using a traditional aircraft carrier in this regard would not only be difficult, but also a suboptimal use of the naval capabilities of these carriers. Most drones are much smaller than conventional carrier-capable aircraft, and using a carrier as their mothership would be a waste of resources, not to mention that some drones are incapable of landing on a carrier in spite of the ship's deck size because of their lack of VTOL capabilities. Another obstacle that drone carrier designers and drone engineers have to overcome is the sheer difficulty of landing on a carrier deck. Safely landing a carrier-capable aircraft atop a rolling naval deck, which is usually around 20% the length of a normal land runway, is one of the most challenging procedures in the entirety of aviation. Doing that with a drone, however, could be even more challenging because the drone needs to be able to do this autonomously without last-second input from the operator. With that in mind, in order for the world's military superpowers to develop truly formidable drone carriers, engineers are simultaneously developing carriers that are adapted to drones and drones which are tailored for maritime takeoff and landing operations. And this is how they do it. Turkey's TCG Anadolu. Turkey is one of the world's foremost developers of military drones. The country actually holds 65% of the world's drone market firmly in its grasp, and it has recently introduced the country's first ever naval carrier, the TCG Anadolu, into service. What was not known at the time of development of the Anadolu was that it would spearhead the symbiosis between drones and carriers. And incredibly, this was completely unintentional. The Anadolu was originally designed to host F-35 Lightning IIs with vertical takeoff and landing ability. However, thanks to politics, the United States is, at the time of recording, blocking Turkey's purchase of the F-35s. Forced to improvise to find an aircraft which could be launched from the Anadolu, Turkey steered the development of two of their drones into the carrier-capable direction. This decision was made in 2020, by which point the Anadolu had already been launched, and that meant the engineers had to retrofit a brand new ship with new tech that would turn it into a floating, sailing drone platform. In a fantastic example of good improvisation, the new additions included drone control stations with satellite terminals for long-range connections, something that wasn't needed with the originally planned F-35s. A complete revamp of the launching and landing system was also needed because the ship was built with the F-35's VSTOL capabilities in mind, and the two drones that would be used with the Anadolu, Bayraktar's TB3 and Kizilima, couldn't take off and land vertically or on a short runway. Therefore, a roller system was installed to assist when launching drones, and an arresting gear system was installed to slow the landing drones down. According to Haluk Bayraktar, the CEO of Bagheri, which is the company producing Bayraktar drones, the landing is the biggest issue with drones, not takeoff. Unlike the F-35s, drones are subject to very high G-shocks upon landing, and turning the Anadolu into a drone-capable carrier required not only work on the ship itself, but also on the development of new drones which were specific to the ship. One of those two drones is the Bayraktar TB3. In November of 2024, it took off from the Anadolu and landed back on it, thus becoming the world's first fixed-wing drone of that size to complete a naval takeoff and landing without the use of an arresting gear, in spite of it being available on the ship. One lesson learned with the development of the TB3, which was designed designed with the intent to take off from and land on a carrier deck, is just how important folding wings are. The TB2, which is a smaller drone by every measurement, cannot be stored aboard the Anadolu because it takes too much space with its fixed wings, but the TB3, which is larger, fits better because of its folding ability. With that test being so successful, Turkish engineers were happy to continue with the development of another carrier-based drone, the Bayraktar Kızılelma. This drone is not only carrier-specific, it's an Anadolu-specific design that's capable of taking off, flying, and landing back on the ship completely autonomously, with the operator mostly pointing and clicking without the need to micromanage it. The Red Apple, which is what Kızılelma stands for, is also one of the world's first combat drones with beyond visual range capabilities, as well as the world's first combat drone which can fly in formation without operator input, relying solely on artificial intelligence. At this time, however, the Anadolu is not yet hosting these drones on board. The TB3 just finished all prototype testing and is only about to start production, and it will take a while to finish enough drones to fill the Anadolu's hangars, while the Kızılelma has not even wrapped up the testing phase. Also, what's going to happen if the US greenlights the sale of F-35s to Turkey? Will the country once again revert the decision and decide to turn the Anadolu back into a conventional carrier, giving the engineers some serious cognitive backlash? Nobody knows. While it's a good start in Turkey's development of a drone carrier, the Anadolu is far from being dedicated for that purpose. What we can see in this case is that any carrier can be used as a drone carrier if the drones are designed to adapt to a specific ship, and if that ship makes significant changes to accommodate the limitations of drone design. What we're seeing with other vessels, however, are ships designed to field many different types of drones, and one such ship is Portugal's João II. Portugal's Dom João II. The multifunctional drone carrier, expected to set sail in the second half of 2026, will become the flagship of Portugal's naval force, as well as Europe's first dedicated drone carrier designed for launching aerial, surface, and below-surface drones. It's particularly interesting to compare it to the Anadolu because we can spot the differences between a dedicated drone carrier and an aircraft carrier that's being used as a drone carrier. The Anadolu is more than twice the length of the João at 232 meters or 761 feet, in comparison with João's 107 meters or 353-foot deck. This, of course, means that the Portuguese ship has a much shorter flight deck of only 94 meters, but you don't necessarily need a longer runway if the drones on board are designed for short takeoff and landing. João's runway will also include a catapult to launch drones, while the Anadolu has a ski ramp. Similar to the Anadolu, João is a modular vessel that can switch between mission profiles by swapping out systems and equipment, blending the capabilities of a conventional landing platform dock with the capabilities of a mothership for unmanned systems. The 7,000-ton ship will be capable of launching the largest of drones the country has at its disposal. This includes the UA Vision Agasa OGS-42, which is a reconnaissance drone that João will be able to deploy in both the VTOL and STOL configurations. Unlike Turkey, Portugal is not planning to use any combat-capable drones with their drone carrier, at least not at this time, but we're talking about a highly adaptable platform here, so it's not out of the realm of possibility for us to see a combat drone deployed from this ship in the future. Instead, the ship is more geared towards unmanned combat vessels. Portugal has been intensely working on developing several of these vessels, including hydrographic research vessels, armed, high-speed autonomous vessels, and autonomous oceanic patrol vessels, all of which will be deployed and recovered by the drone carrier. Portugal also developed underwater unmanned drones, such as the Seacon series of drones, which can be used for mine warfare, search and rescue, and intelligence, surveillance, and reconnaissance missions. The configuration of this vessel implies that it's a dedicated drone carrier, but not a dedicated combat ship, more of a reconfigurable platform that can be used for whatever Portugal's navy needs. During a conflict, it can be used for reconnaissance and warfare, but it's most useful for naval control and intelligence, not for active combat. This is in fact the sole reason it was ever created. Portugal's maritime space covers around 4 million square kilometers, making it the EU's largest coastal state, with an exclusive economic zone being 18 times larger than the country's mainland. That is a hell of a lot of space to cover, and incidentally, Russian ships have been quite active there in the past few years, with the Portuguese Navy tracking 143 vessels along the country's coast between 2022 and 2024. In 2025, things escalated a bit, with 8 vessels entering Portugal's water, and that included at least 1 submarine equipped with long-range missiles and at least 1 Russian spy ship which can destroy undersea cables. This, of course, sparked fear that a cable-cutting incident similar to the one that happened between Finland and Estonia could occur at the diagonally opposite side of the continent. Keeping an eye out for potential breaches of Portugal's waters is going to be the primary job of the João. The ship can simultaneously deploy and control aerial, surface, and underwater drones, set up underwater minefields, and even open fire on enemy vessels with its surface drones, although it must be pointed out that those drones, such as the unmanned oceanic patrol vessel, are still being developed, and it's unlikely they'll be packing too much of a punch. Since all of these drones have to be controlled by someone, there's room on the carrier for 42 drone specialists on top of the 48-strong crew, while the ship can accommodate up to 300 people in case of an emergency. With this configuration, the João will have an approximate range of about 10,000 nautical miles and an endurance of 45 days, which can make it ideal for long-duration expeditionary missions far from home. Mobility is key here, however, as the carrier can be used for a broad spectrum of services. Aside from the remotely operated or autonomous vehicles, the ship can be equipped with medical facilities, science labs, hyperbaric chambers, and storage areas, making it a valuable asset for anything from scientific research to disaster relief and search and rescue missions. S&R missions are the specific reason non-autonomous helicopters operated by onboard pilots will also be stationed on board the ship. Although reconnaissance drones can be extremely valuable as the operation center's eyes and ears during search and rescue, helicopters are crucial for evacuations, and the ship's flight deck will host light, medium, and heavyweight helicopters, such as the August Westland AW101 Merlin, for this very specific purpose. All in all, Portugal will introduce Europe's first dedicated drone carrier into its navy sometime this year, and while it may not be as combat capable as many had hoped for, it is still a huge leap in the development of these two technologies and could ultimately prove invaluable in non-combat operations. Iran's Iris Shahid Bagheri. Another country making big strides in the drone carrier department is Iran, with its Shahid Bagheri drone carrier. The ship is actually a converted container ship called Peregrine, but Iranian shipbuilders added an angled flight deck with a ski ramp and a bunch of UAV carrier systems to make it the country's first dedicated drone carrier. It could also be called a phantom ship, given how much ruckus it caused in 2024 when Twitter became convinced that the ship was launching drones in an attack on New Jersey. In classic American fashion, this rumor was given false credibility when Jeff Van Drew, a member of the Judiciary Committee of the US Congress's House of Representatives, also said that Iran was operating a drone mothership off the coast of New Jersey. This prompted the Department of Defense to deny the claims, and images were released later that very same day showing that the ship was, in fact, not that far away from the coast of Iran, still undergoing sea trials. It's apparently just American media for you. Iranian media isn't much better though, and that's something that should be taken into account when discussing this ship. Everything said needs to be taken with a huge grain of salt, because there's no way of verifying anything, and all information regarding this ship or any other piece of Iranian technology is coming from open source intelligence or Iranian media reports, which exaggerate many things on purpose. Shahid Bagheri is designed to host drones and helicopters, and when it comes to sheer drone versatility, it is the most well-developed drone carrier we've seen so far. Operates Bell 206 and Mi-171 helicopters on top of a Babel 3N, JAS 131, and Homer VTOL drones, and a single Maharaja 6 or a single Gaza drone. The Babel is an ancient design, while the Babel 3N variant is a nautical redesign with a new airframe that grants it longer endurance. The drone is built from composite materials, it's very cheap to build, and serves mainly as a surveillance drone. The JAS 131 is a much more impressive design. This is a highly capable stealth drone that might be more popular under the name Kaher 313. Originally intended to be a manned fighter, it was turned into an unmanned aerial vehicle, and according to most reputable aeronautical engineers, it is highly likely a terrible drone as it's too small to serve as a combat aircraft, and no one really knows its intended purpose. Shahid Bagheri will also seemingly feature the Homer VTOL drone. This is a bit of overkill because VTOL capability is not necessary for a drone to take off from and land on this ship, as the ship's runway is 180 meters or 590 feet long. Homer is another reconnaissance drone capable of nighttime operations, and it's also equipped for electronic warfare. However, not much is known about it since it is still in the testing phase. None of these drones are going to make any military adversary shudder with fear, but two drones do present potential problems. With its very long runway, Iran's drone carrier is capable of launching the aforementioned Maharaja 6 and the new super heavy Gaza drone. The Maharaja 6 is a multi-purpose drone capable of carrying 4 guided missiles or bombs with a range of about 500 kilometers and an endurance of 12 hours. This is not that impressive, but it does mean that Iran technically possesses the ability to launch a combat drone from one of its ships. What's worrying is the possibility of launching the Gaza drone. drone. Gaza, officially known as the Shahid 149, is an unmanned combat drone that started production in 2022. Officially, only 3 of them were ever made, but that's highly unlikely because that's exactly what Iran wants everyone to think. This is by far the most advanced long-range drone Iran has ever designed, similar in role and appearance to the iconic MQ-9 Reaper. It boasts an alleged combat range of 1,600 miles or 2,500 kilometers, with a service ceiling of 11 kilometers or 35,000 feet. It can also loiter up there for 24 hours and is incredibly well armed with 13 hardpoints for bombs. Aside from its combat role, it's remarkably well equipped for reconnaissance, at least by Iran standards, with a thermal camera and a system for stealth aircraft detection, among other features. Something that the Iranian media doesn't like to mention, while a lot of experts pointed out, is that the wingspan of both the Gaza drone and the Mahajr 6 makes it difficult to operate on Iran's new drone carrier. Not impossible, but retrieving the drone is definitely a challenge, and Iran is yet to demonstrate if those arresting gears are actually working. With all of that said, Iranian sources claim that the carrier is capable of deploying and controlling 60 UAVs, all of its helicopters, and all of its air defense systems at the same time. Some of the state's media also shows the use of arresting wires that help with landing, which would be a sensible solution for all drones, particularly the heavier ones. Aside from drones and helicopters, Shahid Bagheri is armed with a single 30mm autocannon for point defense, as well as anti-ship and anti-aircraft missiles. It can also deploy up to 30 smaller boats and fast attack craft, which includes smaller vessels armed with missiles. Additionally, Iranian state officials boasted an operational range of 22,000 nautical miles, a year-long on-sea endurance, an onboard hospital, and a football pitch, or soccer for Americans, because apparently having a football pitch is what really makes or breaks a drone carrier, not the ability to, carry drones. On a serious note, though, it's highly likely that the Shahid Bagheri is a drone carrier in writing only. This is something we touched upon in the video dedicated to this carrier, which you can take a look at if you're interested in a detailed breakdown. But Shahid Bagheri is yet to demonstrate its ability of deploying and retrieving drones. It probably can do that with smaller drones, such as the Ababil 3N, but the claim of deploying and retrieving the Mahajr 6 or the Gaza drone is a bit difficult to believe because of the sheer size of them, specifically their wingspan. What could pose a threat to Iran's adversaries is the use of non-reusable one-way drones, such as the Shahid 136, which is a very potent kamikaze drone. It can definitely be launched from the ship's deck, and since Iran has demonstrated that it can produce this drone in copious numbers, the possibility of a swarm of them being launched seems far more realistic. However, how many of these drones could the carrier host, and how many could it effectively manage in combat is just about anybody's guess. On a broader scale, Iran lacks anti-air defenses and escort vessels to protect the Shahid Bagheri, which severely limits its potential for effective combat engagements. In spite of the clear exaggerations that come with the Shahid Bagheri, mostly perpetrated by state media, adversaries must not underestimate the possibility of a hidden ace up Iran's sleeve. Iran is the only military power in the world basing the majority of its fighting force around drones. It's also more than likely that the country is in possession of, or at least in the process of development, of a drone that we haven't spoken about because we, frankly, don't know it exists. A retrievable, combat-capable drone that can be effectively used aboard the Shahid Bagheri. In conclusion, this carrier is the biggest mystery of them all. It could be a completely dysfunctional hunk of metal that's going to spend most of the time in maintenance, or it could prove to be a valuable carrier capable of projecting power all over the world. The truth is, we won't know until we see it in action, and for everybody's sake, we hope we never do, given America's military build-up at the time I'm recording this episode. Not sure how likely that's going to be, guys. China's Type 076 landing helicopter dog. The Sichuan, which is less of a mouthful than the ship's official designation, attracted a lot of attention on the military tech front because of its drone carrying capability. You can take a look at our recently published video on it for a deeper dive, but in a nutshell, China completely redesigned the core idea of an amphibious assault vessel into a drone and helicopter carrier. Every 3-inch on the inside was turned into a drone hangar and workshop, the elevator ropes are made from carbon fiber, and the launching system is magnetic, which is by far the most advanced aircraft launching system in existence. At the same time, this ship checks all the boxes of an amphibious assault vessel. It can fit more than 1,000 Marines on board it, and it can deploy landing craft, but it's the drones that really make it stand out. One of those drones is the Guizhou WZ-7 Soaring Dragon, an aerial reconnaissance drone on paper which can be used to provide targeting data for cruise missiles and anti-ship missiles. The Soaring Dragon is larger than most UAVs, and yet it can be launched and it can land on top of China's new assault ship. The same can be said for the other drone, the Hongdu GJ-11 Sharp Sword, which is an aerial recon and precision strike drone that can be armed with up to 2,000 kilos or 4,400 pounds of internal payload. It's another heavy drone that can be launched from the Szechuan's deck thanks to its innovative magnetic launch system. These two drones are intended to work alongside the onboard helicopters and the landing craft used by the Marines during an operation, predominantly as the forward observers for missiles and generally better situational awareness. The Szechuan is only one of 3 existing ships to utilize the electromagnetic catapult technology that allows such big drones to take off from the ship's runway, and that is incredibly important as drones are more fragile than helicopters and manned aircraft. Electromagnetic catapults don't put nearly as much stress on drones as steam catapults do, but all technology comes with its drawbacks. Like most politicians and tech bros, it's very power-hungry, requiring stable voltage, which can be an issue if you're running 1,000 systems and different operations all at once. Magnets also don't work well in wet environments, and the at-sea humidity can reduce their effectiveness. Most important, electromagnetic systems require a lot of maintenance, and having to dock your ship in the midst of combat to undergo maintenance is something most commanders would rather not do. In spite of that, when it works, the electromagnetic catapult is a fantastic way of launching big, bulky drones, and if we compare that to Iran, we can see the difference between actually performing and claiming to be capable of doing something, which is in theory almost impossible. Now, at this point, a pattern has started to emerge. No drone carrier is a drone-only carrier. Even the Portuguese ship, which is the most drone-exclusive out of all the carriers we've talked about today, made room for smaller attack craft as well as helicopters, which are crucial in disaster relief and search and rescue missions. Instead of hosting hundreds of drones and deploying them in swarms, the designation drone carrier means that the ship is built, or in Iran's case, refitted to accommodate and operate drones, but not drones exclusively, and the last ship we'll talk about that fits into that category is the new and upcoming class of British carriers. The UK's modified drone carriers. The Royal Navy has no intentions, at least not at this point in time, to build entirely new ships to fill the drone-shaped hole in its fleet. It did play with that idea for a while and designed the UXV Combatant during the warship era when everything looked like Pyramid Head from Silent Hill, but that ship never went into production. What is happening, however, is the retrofitting of the 2 carriers from the Queen Elizabeth class to turn them into drone-capable carriers. Both of the carriers in the class, HMS Prince of Wales and HMS Queen Elizabeth, are state-of-the-art machines which, as someone in the decision-making circles noticed, could be improved by making them drone-capable. Called Project Ark Royal, the 2 carriers are being retrofitted with arresting gear and assisted launch equipment to make drone takeoff and landing possible. At the time of writing, 2 types of drones were already successfully launched and retrieved, the Quintique Banshee Jet 80 Plus and the General Atomics Mojave drone, but what the Royal Navy is really aiming at is Project Vixen. This project is simultaneously developing new drones to be used with these 2 carriers and testing the launching and retrieving capabilities of the vessels. Originally, F-35s were used with the Queen Elizabeth class because of the ship's SVTOL configuration. They were the only fixed-wing combat aircraft which could take off from such a short runway and land without arresting gears. However, at some point, someone ran the numbers and realized that if a few changes to the launching system are made, both carriers in the class could carry a bigger payload if they just made the change to drones, because drones are comparatively lighter than F-35s. Project Vixen aims to install electromagnetic catapults, the same ones China has now got on 2 of their ships aboard both Queen Elizabeth class carriers to allow the launching of drones. Additionally, a new drone is currently in development as a dedicated airborne early warning system for the carriers. This new drone will replace the Merlin HM2 Crow's Nest helicopter by 2030, and while not much is known about it, we do know that we're looking at a fixed-wing, unmanned aircraft. Aside from reconnaissance, Vixen should, in theory, be used for surveillance, electronic warfare, strikes, and air-to-air refueling. Other drones are in consideration for these roles, and although no concrete data is available, Royal Navy briefings used Boeing's MQ-28 Ghost Bat as an example of the rough size of their ideal drone. The Ghost Bat is an Australian design used for combat and as a loyal wingman, programmed to provide support to manned combat aircraft. It is the second drone ever, after the aforementioned Turkish Bayraktar Kızıl Elma, to destroy a target beyond visual range. If the new secret drones really are in that class of drone, they're going to be a formidable force. Of the other 2 drones, which were successfully tested on Queen Elizabeth-class carriers, the Kinteek Banshee Jet 80 Plus and the General Atomics Mojave. The latter is much more interesting as it can serve as a close air support drone. The Mojave can be armed with air-to-surface missiles, miniguns, and several bombs, albeit not at the same time. With a maximum takeoff weight of 7,000 pounds or just short of 3,200 kilos and a wingspan of 16 meters or 52 feet, launching this drone is a challenge, but a challenge that the two carriers overcame. With that in mind, it's possible that we will witness a diverse swarm of drones aboard the two Queen Elizabeth-class destroyers in the near future, with strike drones, close air support, recon and surveillance, and armed overwatch drones all being in development, completing a daunting task force of unmanned aerial vehicles. Drone-capable carriers, carrier-capable drones, and what it means for war. We can say one thing for certain after combing through these examples carefully. The development of drone-capable carriers and carrier-capable drones is trending and will likely see more countries follow that trend. 3 questions do need concrete answers, though. How do drone-capable carriers differ from conventional carriers? How do carrier-capable drones differ from land-launched and retrieved drones? And finally, how is this going to impact naval warfare? To answer the first question, drone-capable carriers don't require as much room as conventional carriers. There's no human presence on board these systems, and that allows for smaller designs which are also inherently easier to stow. Although it doesn't really have anything to do with the question at hand, that's the same reason navies launch drones from smaller classes of ship. They don't need very long runways since they're not as heavy. Drone-capable carriers will also need to allot more room aboard their ships for drone operators, though the final goal is to have all drones take off, conduct an operation, and land completely autonomously. An operator needs to be ready to take control of the drone at any given point. Also, missions that require ultimate precision, such as strike missions or close air support, most likely won't be conducted autonomously. Operation command centers will need to make room, both physically and in their command framework, for drone operators. Finally, drones aren't launched the same way as manned aircraft. Some require launching platforms, others need catapults, and this depends on the type of drone and the length and design of the runway. Either way, carriers that would otherwise utilize one method of aircraft takeoff will have to make modifications to accommodate drones. Take the Queen Elizabeth class as an example. The carriers have to make the switch from short takeoff vertical landing to electromagnetic catapults because they'll be ditching the F-35s and onboarding a bunch of new drones which can't take off or land without the help of a catapult and arresting gears. When it comes to the difference between conventional and carrier-capable drones, the answer is more difficult to come by, as we're now witnessing the first generation of seriously high-tech, dedicated, carrier-capable drones. Most of them are only being tested at this point, while the majority of drones nowadays launched from carriers actually aren't carrier-specific. One challenge related to the final point of the last question is carrier-capable drones will need to be able to take off from and land on very short runways. The United States is currently experimenting with different kinds of drones, launching them from different ship classes to see which kind of drone works best with which class of vessel. In December of 2025, Lucas, a one-way kamikaze drone, was launched for the first time from the flight deck of the USS Santa Barbara, a littoral combat ship. Thanks to its size, propulsion system, and easy launch method, Lucas could, in theory, be launched from a much smaller vessel as well. All of this is to say that the carriers are the ones doing the heavy lifting here. They're the ones who are going to have to do the majority of adaptations to fit the drones aboard, not the other way around. And finally, how's this going to affect warfare? Well, it might make some people trigger happy. Since drones are capable of effectively replacing manned aircraft in certain situations, it's possible that commanders of certain military forces won't hesitate as much before commanding an assault. After all, if you down a drone, no one dies. We're also probably looking at a majorly unmanned force. In 2022, during the Tailhook Association Symposium, several military officials said it's the US Navy's goal for at least 60% of its carrier air wing to be uncrewed by 2045. This could result in a human-drone partnership along the lines of the Law Wingman program, while carrier groups could face off at an even greater distance from now on because of fear of long-range drone strikes. It's unlikely that drones will ever completely replace piloted aircraft, but why would you risk a pilot's life if the same mission can be completed by an autonomous aircraft? In the same way, drones won't ever completely remove helicopters or landing units from amphibious assault vessels. You need the precision of a human pilot for certain operations, the same way you need boots on the ground to establish territory control. Drones won't replace human soldiers in that regard. They will, however, become an everyday occurrence even with marine infantry. The reliance on drones for recon and close air support will become more and more common. Speaking of reconnaissance, it's going to become much easier than it is now, alongside intelligence and surveillance, especially for nations like Turkey, which have a seemingly endless supply of drones. We're also going to witness the spreading of the mothership idea into aviation. Airbus has already announced their plans to develop an air carrier for drones, which would deploy smaller drones from above. If the idea leaves the drawing board and becomes reality, this will be yet another way of drone delivery. Last but not least, the rise of drone carriers could result in more attrition and more casualties. Drones are cheap to produce, easy to operate, and they kill and destroy just as easily. It's cheaper for a carrier to launch 24 suicide drones than a pair of F-35s for a strike mission. And with that in mind, we might be entering an unprecedented era of warfare. Thank you for watching.